Let's look at a couple examples in solving trig equations where we're going to have to use technology to actually find our solution. So for this first example, we have 3 times the sine of theta is equal to 1. So just using our strategies that we've seen so far, we just need to isolate that sine of theta. So that means we're going to divide both sides by 3. And if we do that, we'll have the sine of theta is equal to 1/3. So right off the bat, you should recognize that this 1/3 is not one of our normal unit circle values for sine. It's not a half or 3/2 or 2/2. It's not a 0 or 1 or -1, right? So it's not one of our nice unit circle values. So how do we figure out the angle that corresponds to sine equaling 1/3? Well, we're going to have to use our inverse trig functions. Okay, so just let's take a step to the side here and just review our inverse trig. So when we take an inverse trig or inverse sine of some number, we are going to get an angle. So we're going to get a theta, and that theta has to be between a -π/2 and a +π/2. So that means theta has to be somewhere in the first or fourth quadrant, and it would rotate clockwise down into the fourth quadrant. Okay, so it's not going to rotate around the unit circle into the fourth quadrant. It's going to start at the x-axis and rotates downwards clockwise into the fourth quadrant. That's where we get this -π/2 from. Okay, if we did this with cosine, so theta would equal the inverse cosine of, again, just some number, right? For cosine, when we compute inverse cosine, the range is going to be from 0 to pi. Okay, so inverse cosine is going to produce an angle in the first and second quadrants. Okay, and then if we did inverse tangent, so theta is equal to the inverse tangent of, again, some value. And that theta also has to be between -π/2 and +π/2, although this time we cannot include the -π/2 or the +π/2. So there's strict inequalities here because tangent is actually undefined at π/2 and -π/2. It has those vertical asymptotes on the graph. Okay, so the range for inverse sine is from -π/2 to +π/2, including those endpoints. The range for inverse cosine is 0 to pi, including the endpoints. And then the range for inverse tangent is from -π/2 to +π/2 again, but not including the endpoints. So going back to our problem here, we have the sine of theta is equal to 1/3. So that means theta is going to equal the inverse sine of 1/3. Okay, so if we compute that on our calculator, and make sure you're in radian mode here, we're going to get theta is equal to 0.3398. Now the decimal does continue on. I'm just going to round it to 4 digits for now. Okay, so also remember, when sine of theta is equal to 1/3, this happens, so sine is positive in the first and the second quadrants. Okay, so where is that 0.3398 angle? Well, inverse sine produces an angle between -π/2 and +π/2, which means it's in the first quadrant. So this 0.3398 angle is the angle in the first quadrant. Okay, so how do we figure out what the second quadrant angle looks like? So let me draw a little illustration here, a graph of our unit circle. Okay, we just found the angle in the first quadrant. So this little angle here, so the acute angle in the first quadrant, and I know that that angle is 0.3398. Okay, that acute angle in the first quadrant serves as a reference angle for the angle that's in the second quadrant. And so if I drew this in the second quadrant, we have this acute angle here. That's the reference angle, and it is also 0.3398. Okay, but the 0.3398 is not the rotation from the positive x-axis to the second quadrant. It's the rotation from our terminal side of our angle to the negative x-axis. So how do we figure out the angle of rotation from the x-axis all the way, the positive x-axis all the way to that terminal side? Well, if we rotated all the way from the positive x-axis to the negative x-axis, that would be pi. But we're going to stop short. We're going to stop 0.3398 radians before the negative x-axis. So that means our second theta is going to be pi minus 0.3398. And if we compute that, we will end up getting that the second theta is equal to 2.8018. Okay, so we have our solution here, and this we're going to list out our 0 to 2 pi just like we've done in the past. Theta will equal 0.3398 or 2.8018. And again, that's in the first and the second quadrant, which again should make sense because that's where sine is positive. So how do we express that there's infinitely many solutions? Just like we did before. With sine, we're going to add in a 2 pi k. So theta could be 0.3398 plus 2 pi k, or it could be 2.8018 plus 2 pi k. And whether or not you have to give the solutions on 0 to pi or express all the solutions just depends on the directions of whatever problem you're looking for. What's your end goal that you're trying to solve for? Okay. All right, let's try one more here. We have 7 minus the tangent of x is equal to 9. Just like we've seen before, we want to isolate that tangent. So let's subtract 7 from both sides, and that will leave me with a negative tangent x is equal to 2. And then we don't want the tangent to be negative, so we'll multiply both sides by a negative 1 to change the sign. So we'll have tangent of x is equal to a negative 2. Now, when you see that negative 2, you might be tempted to think that because the unit circle, the highest it ever goes, the lowest it ever goes is between negative 1 and 1, right? That's the boundaries of the unit circle is plus or minus 1. You might think that this is not going to have a solution, but that only really works for sine and cosine, okay? The range for sine and cosine is negative 1 and 1. The range for tangent is negative infinity to positive infinity. So we actually can have tangent of x equals a negative 2. But again, negative 2 is not one of our nice unit circle values, so we're going to have to do our inverse tangent. So to find this, x is equal to the inverse tangent of a negative 2. Okay, and again, remember, where is tangent negative? Tangent is negative in quadrant 2 and in quadrant 4, right? But, so there are two values that make tangent equal to a negative 2 on the unit circle. But there's only one that we're going to get when we do the inverse tangent. Okay, and if you remember, inverse tangent is always going to produce an answer between negative pi over 2 and positive pi over 2. So that's somewhere in the fourth quadrant or in the first quadrant. Okay, so if we compute that inverse tangent of negative 2, we will get that x is equal to a negative 1.1071. And again, that is a negative value, which means it's a negative angle. So that is a rotation from the x-axis downwards into the fourth quadrant. So it's rotating downwards, or clockwise, I should say. It's rotating clockwise into the fourth quadrant. Okay, so that's the angle we just found. And that angle is not between 0 and 2 pi. So how do I find, but it is the answer in the fourth quadrant. So we could use that. How do I find the angles that are in the second and fourth quadrant, but also between 0 and 2 pi? Okay, so because it's tangent, remember that solutions are always off by a distance of pi. So if my solution here in the fourth quadrant is a negative 1.1071, there's another solution in the second quadrant that I can get to just by adding pi to it. Okay, that will give me the solution in the second quadrant that is between 0 and 2 pi. And if I were to add pi again, I will end up back at the same location in the fourth quadrant, but now I've rotated in a positive direction. So it'll be in the fourth quadrant with a positive angle. So if I take that negative 1.1071 and I add a pi to it, I will get to I will get 2.0344, and that is an angle in the second quadrant. And if I take that 2.0344 and I add a pi to that, then I will end up with 5.1760. And that's in the fourth quadrant with a positive value between 0 and 2 pi. Okay, so I can express my solutions as x equals 2.0344 and 5.1760. And again, those are the solutions on the interval from 0 to 2 pi. Okay. Now, if I wanted to express the infinitely many solutions, I only have to take one of those solutions and do a plus pi k. And in fact, I'm not actually going to use either of those. I'm going to use the one that I originally got from doing the inverse tangent, because that's how I got those two, right? So to express my infinitely many solutions, I'm going to say x is equal to a negative 1.1071 plus pi k.